All right, so again, the way we write these compounds down is we write the symbols for the atoms that comprise them, and then we use a subscript to show how many of those atoms are there. If there's only one atom there, we don't write a 1, right? We leave that subscript off. So here is table salt, sodium chloride, carbon dioxide. You guys told me that one earlier. So let me ask you, if I have 15 carbon dioxides, how many oxygens would I have? 30, right? Because there's 2 oxygens for every carbon dioxide. Here's sucrose, C12H22O11. So let me ask you, if I had 3 moles of sucrose, how many hydrogen atoms would I have? That's a little more complicated. Let's make sure we understand it. So if we have 3 moles of sucrose, I want to know atoms of hydrogen. Somebody talk me through it. What do we do? First of all, I need to know what sucrose is. So it is C12H22O11. Now what do I do? Put 3 in front of that. So that means 3 moles of sucrose, okay? So now how many atoms of hydrogen? Well, how many moles of hydrogen? 66 moles of hydrogen is there, right? 3 times 22 is 66 moles of hydrogen. Are you okay with that? If we want to know how many moles of an atom inside our compound, we just say how many moles of the compound multiplied by how many atoms in that compound of that type. Okay? Another way to do this would be this. I got 3 moles of C12H22O11. Okay? There's 22 moles of hydrogen in 1 mole of C12H22O11. Because this is what the compound tells me, right? This thing right here tells me inside my molecule, there's 12 carbons, there's 22 hydrogens, there's 11 oxygens. So in a mole of these, there would be 12 moles, 22 moles, 11 moles. Okay? So can you see that this is how we get 66 moles of hydrogen? Now how many atoms is that? 66 times Avogadro's number is right. There's 6.022 times 10 to the 23 atoms in 1 mole. That's the definition of Avogadro's number, right? So moles will cancel, moles of the stuff will cancel, and I'm left with 66 times Avogadro's number atoms of hydrogen, all right? Anytime you see a formula like this, it tells me if I have one of them, how many atoms of each type is there, okay? If I have a mole of them, how many moles of each type is there, okay? Because a mole is just a scale factor, right? If we think about it in this way, I got 1 CO2, I've got 1 carbon, I've got 2 oxygens. If I got a dozen CO2s, they got a dozen carbons, 2 dozen oxygens. Do you agree with that? Mole works the same way. Just like a dozen means 12, mole means 6.022 times 10 to the 23. Okay? So if I got a dozen of these, I got a dozen of those, and 2 dozen of those. If I got a mole of these, I got a mole of those, 2 moles of those. Okay? Does that make sense if we think about it that way? Yes, no, maybe? So again, the subscripts tell me how many of each atom is there in 1 molecule. Or in a mole of molecules, how many moles of each atom is there? Okay? And we can always work at either scale. We can work on the atom basis or the mole basis. For calculations, we typically work at the mole basis because that's big enough things that we can go measure, okay? But that's just a scaled up version of the atom basis of what's going on in 1 molecule. So we talked about this a little bit before,
but that subscript that's there is part of the definition of that particular molecule, of that chemical compound. If we change that subscript, we change the compound. And the best example I can show you is carbon monoxide versus carbon dioxide. So those are two completely different compounds. One is the thing that we breathe out and that plants use to make energy. The other is the byproduct of combustion from your internal combustion engine and will suffocate you and kill you if you breathe it. So how do we know what order to list elements in if we're making a compound, right? So table salt, sodium chloride. How do I know the sodium comes first and the chloride comes second? Why is it NaCl and not ClNa? The things that are more metal-like come first. So remember when we looked at the periodic table, we said that metals are on the left-hand side of the periodic table and toward the bottom. Non-metals are toward the right of the periodic table. So that's how we put them together. The things that are more metallic come first. The things that are less metallic come next. Sugar up there is kind of an exception to that because that's an organic molecule. They got their own rules. So again, reminding you, metals found on the left side of the periodic table, non-metals found on the right side of the periodic table. So you guys tell me, if I have something that has, say, 3 moles of oxygen and 1 mole of sulfur, how would I write a formula for that based on these rules? So how do you know which one comes first? Look at a periodic table. Tell me the column number that each one of those things is in on the periodic table. They're both in the same column, right? So we can't use the left-right to determine which one's more metallic than the other, right? If one were more on the left, we'd say it was the metal and it would come first. If one was more on the right, we'd say it was the non-metal. But they're both in the same column. So when they're both in the same column, things get more metallic as we go down the periodic table, okay? So which one's further down? Sulfur. So sulfur comes first. And so you're absolutely right. We write that as S and then O, and then there's 3 O's there, okay? So SO3 would be how we'd write that. If you look on the periodic table, you'll see that nitrogen is to the left of oxygen, and that's why we see NO2 instead of O2N or anything like that. I don't recommend that you memorize this, but this is kind of the general order that things would come from left to right in a chemical formula, okay? But if you understand our metal, non-metal thing, there's really no point to memorize this. There are some exceptions, okay? So even though hydrogen is all the way in the far left, hydrogen's usually written on the right in things like OH minus. The reason for that is hydrogen can only make a single bond. It can only make one bond to anything. And so it usually comes last. In organic things, carbon comes first because carbon is the basis of all organic things. All right, help me out here. So I've got 2 aluminum atoms to every 3 oxygen atoms. How can I write a formula for that? Which one comes first, and how do I denote how many are there? Yeah, aluminum comes first. So Al, and then oxygen comes second. And then how do I denote how many are there? It does. So how do I put them on the thing? Subscript. So how many for aluminum? And how many for oxygen? So this is aluminum oxide. All right. How about 3 oxygens to every sulfur? We did that one already. That's SO3. 4 chlorines to every carbon. Carbon or chlorine comes first. Which one? How do you know? It is more to the left. So we got a carbon. We got chlorine. Where does the subscript go? And what's the subscript? Carbon tetrachloride. All right.